Hello everybody, this is Gordon. We're back for a second set of problems in classical mechanics, the laws of motion. The first one, velocity of an object is constant without non-zero net force. An object in motion stays in motion. An object at rest stays at rest. Second one, force is equal to mass times acceleration, the relationship between force, mass, and acceleration. The third, no force occurs by itself. Our first problem, what is the weight of an object with mass 5 kilogram? What is its acceleration when acted upon by a force of 100 newtons? So we're asked to find weight and acceleration. We're given a mass of 5 kilograms, a force of 100 newtons providing the acceleration. Weight is mass times acceleration. Weight's a force. When we're talking about weight, we use, of course, the gravitational constant here on the surface of Earth. And so our weight is going to be 5 kilograms times 9.8 meters per second squared. When we do the arithmetic, the weight is 49 newtons. The acceleration, we'll use the equation force is equal to mass times acceleration. And since we'll solve that for acceleration first. Acceleration force divided by mass. We're given a force of 100 newtons. The mass is 5 kilograms. And the arithmetic provides us with an answer of 20 meters per second squared. The second problem, an empty truck mass 2,000 kilograms has a maximum acceleration of 1 meter per second squared. We're asked to find its acceleration when it has a 1,000 kilogram load. The max acceleration provides us with the maximum amount of force that the truck can provide, and we'll use that force to calculate the acceleration with the additional mass. And so the max force is equal to the mass of the truck, empty, 2,000 kilograms times its maximum acceleration, 1 meter per second squared, giving us the maximum force that the truck can provide as 2,000 newtons. The acceleration when the truck is loaded will be, as before, force divided by mass. This is going to be the maximum force that the truck can provide divided by the mass of the truck as it's loaded. So the original weight, 2,000 kilograms, plus the additional 1,000 kilograms. It's 2,000 divided by 3,000. Do it easy. 2/3. And the answer, of course, meters per second squared. The third question that we have, the brakes of a 1,000 kilogram car exert a force of 3,000 newtons. We're asked to find out how long it will take to come to a stop from a velocity of 30 meters per second, and how far will it travel. So we're given m as 1,000 kilograms, F as negative 3,000 newtons. The deceleration, it's a retarding force, a force applied in the opposite direction of motion, so we'll give it a negative sign. The initial velocity, 30 meters per second. We're asked to find time and the distance that it will travel. Again, we'll use the second law of motion, relationship between force, mass, and acceleration. A as before, acceleration force divided by mass, so 3,000 newtons divided by the 1,000 kilograms given. We'll find the deceleration of the car as negative 3 meters per second squared. And then we can use that in equations from earlier problem sets. V is equal to V sub 0 plus AT, the general equation for velocity. We need to find time, so we'll solve that equation for time. We have T is equal to the difference of the velocities divided by the acceleration. And so we know that V final is 0. The initial velocity is 30 meters per second. The acceleration we just calculated as negative 3 meters per second. So we have, for our time, negative 30 meters per second divided by negative 3 meters per second squared to provide us with a time of 10 seconds. Using another equation from an earlier problem set, distance is equal to velocity, initial velocity times time, plus 1/2 acceleration times time squared. We have the distance traveled, 30 meters per second, times 10 seconds, plus 1/2 negative 3 meters per second squared times 10 seconds squared. That second term is going to equal negative 150. The first term is 300. And so we come up with a distance traveled of 150 meters. And that's that problem. Our fourth question, a 3,200 pound elevator cab is supported by a cable with a maximum safe tension of 4,000 pounds. We're asked to find the greatest acceleration, upward acceleration the cab can have. And so problem again is a relatively straightforward one. We're looking for acceleration, which is force divided by mass. We need to know what force is, and we need to know what the mass is. We're given the weight of the car, and of course weight is equal to mass times the gravitational constant. So mass, weight divided by g. The weight is given as 3,200 pounds. Gravitational constant in the English system, 32 feet per second squared, giving a mass of 100 slugs. The force, the maximum force that can be applied, is the difference between the max safe load on the cable and the weight of the car. If the cable can support as much as 4,000 pounds and the car weighs 3,200 pounds, then the maximum force that can be applied before breaking the cable is 800 pounds. So the acceleration is 800 pounds divided by the 100 slugs, which is the mass of the car. And we come up with an answer of 8 feet per second squared as the maximum acceleration for the car. The final problem, a mass of 50 kilograms and another of 30 kilograms are suspended by a rope on either side of a frictionless pulley. We're asked to find the acceleration of each weight. Obviously, the acceleration of each weight is going to be the same. The cable does not stretch. One is just going to be a certain value up, and the other is going to be a certain value down, so positive and negative along a y-axis. The net force, which is the tension on the lines, is equal to mass times gravitational constant. One force being up, the other force being down. That's why the 30 is negative. And so we come up with 20 kilograms times 9.8 meters per second squared, the net force being 196 newtons. The acceleration, force divided by mass, as before, 196 newtons. We're going to divide that by the total mass of the system, 30 plus 50 kilograms. And when we do that, we come up with 196 newtons divided by 80 kg, or an acceleration of 2.45 meters per second. And that's it. Thanks for watching.